Hi students, how are you? I hope that you are all preparing well for your JEE mains examination. Okay, so today also I am going to explain very important problems which were given in previous JEE mains examinations from the chapters limits, continuity, differentiation. Okay now, so without wasting your time, so let us see the first problem. So this problem is asked in 2018 JEE mains examination. So the question is, here there is a set, the set is there. In that set, there is a function f of x is equal to modulus of x minus pi into e to the power of modulus of x minus 1 into sine of modulus of x. There is a function is there where is a not differentiable at t. He is saying that it is not differentiable at t. He declared that it is not differentiable at a t where t belongs to real numbers, and that means it is not at all differentiable. Then the set S is equal to, so the set S is equal to, so 0 to pi 0 na null set. So he is saying that, okay. Then how to proceed this type of problem? So he is saying that this function is not differentiable. His function is not differentiable. Okay now. Right, then how to proceed this problem? So to do this type of problem, there is a very interesting concept is there. So let us see that concept. If we know that concept, such type of event, so this is a product of the functions 1, 2, 3. So this is a product of the three functions. It is there, whether it is a differentiable or not differentiable, or based on this there is a one important concept is there. So let us see the concept here. What is that concept is? If there is a function, it is a product of two functions or three functions or four functions, whatever may be that. F of x is equal to h of x into g of x. It is a product of two functions. Okay now. First to see the function h of x. It is not differentiable at x is equal to a. It is not differentiable at x is equal to a. The second function is g of a is equal to 0. But the second function, where the function is, first function is not differentiable, there the g of that value is equal to 0, then this function is differentiable for all x belongs to real number. That means the first function is not differentiable at x is equal to a. The function, first function is not differentiable at x is equal to a. That means here there is a breakage is there. So this is h of x function. Okay now. What is your g of x function? No, g of a is equal to 0 means what? So your function is this. So this is equal to g of a function, g of x function. This is your g of x function. At x is equal to a, it is intersecting the x-axis. Okay. So here at x is equal to a, what is g of a? It is 0. Y coordinate is 0. On x-axis, y coordinate is 0. Then the product f of x and to g of x is equal to, is differentiable at x is equal to a. It is differentiable at x is equal to a. He is saying that. Understand, the product will be differentiable at x is equal to a. Okay now, right. So this is a concept that we have to learn. Okay. Based on this, we will go. We are going to solve this problem. Welcome back to this problem. First, consider this function. So that is equal to a modulus of x minus 4. It is not differentiable at x is equal to pi. It is very clear. It is not differentiable at x is equal to pi. Why? Because, so if you see the graph of this modulus of x minus 5, so this will be this type of this function. This will be x minus 5 means modulus of x. So minus 5 means it will move to rightward. It will come to this side. Okay. So this is equal to, at this time x is equal to pi. At x is equal to pi. Okay. The function is not differentiable. If you observe, sine of x, that is equal to sine of modulus of pi value is 0. It is not differentiable at x is equal to 5, but sine of pi value is 0. So, according to the previous concept, so f of x is equal to modulus of x minus pi and sin x. If you consider up to here, it is differentiable at x is equal to 0. Differentiable at x is equal to, pi. Differentiable at x is equal to pi. Now, take this function now, e power x, e power modulus of x minus 1. It is not differentiable, at x is equal to 0, at x is equal to 0. If you observe, you draw the graph, e power modulus of minus 1, you will get a sharp edge at x is equal to 0. Okay now? Right. It is not differentiable at x is equal to 0. If you observe here, sin of modulus of x, that is equal to sin of modulus of 0 is equal to 0. Therefore, the function f of x is equal to modulus of x, e to the power of modulus of x minus 1 into sin x is differentiable at x is equal to 0. Differentiable at x is equal to 0. Okay now, so again, if you take these two are over, these two also, if you take, this is also, if x minus pi e power modulus of x minus 1, they are also the same concept. If you follow the same logic, they are also differentiable. So, from this we can say that the function is not differentiable at t is wrong. That means it is differentiable at x is equal to 0 and x is equal to pi, and some x is equal to somewhere also it is differentiable. Therefore, this not, but he is saying that not differentiable at t, he is saying, but therefore, this set does not contain any element. Therefore, option B is your correct answer. Okay na? I hope that you understand this solution. So, let us go for next problem. Dear students, welcome to the second problem. So, for x belongs to open bracket 0 comma 1 by 4, if the derivative of tan inverse of 6x root x upon 1 minus 9x cube is root x into 9x, then g of x is equal to how much? So, here what is the function given here? The derivative of, so for example, y is equal to tan inverse of 6 root x by 1 minus 9x cube. Okay now. So, the derivative of, that means the dy by dx of this function is root x into g of x. Then what is the g of x value he is asking. Okay. So, if you straight away find the derivative of this function as it is, the problem will be very, very difficult. Why? Because tan inverse of x means, what is the derivative of tan inverse of x? 1 by 1 plus this whole x square into, again you have to do the u by v formula. So, very, very difficult. So, before doing this, let us simplify this function. Before finding the derivative, let us simplify this function. So, I will do like this, y is equal to tan inverse of 2 into 3x root x rho. X root x means x power 3 by 2 by 1 minus, this can I write down 3 into x power 3 by 2 whole square. Can I adjust these values? Yes, I can adjust. Why? 2 into 3, 6. X root x means x power 3 by 2. So, this is 9x cube means 3 into x power 3 by 2 whole square. Why? Because 3 square is 9, x power 3 by 2 whole square, 2 will get cancelled. So, this is equal to, y is equal to tan inverse of 2x by 1 minus x square. That is equal to tan inverse of 2x by 1 minus x square is equal to 2 times tan inverse of x. We have one formula from inverse trigonometric function. So, this is equal to, y is equal to 2 times tan inverse of x power 3 by 2. Understand? See here. So, just what I did is, I have simplified the given function to this form. So, finding the derivative of this function is very, very easy. Okay na? So, what is the derivative of this function? Dy by dx is equal to 2 times tan inverse of x derivative, that is 1 by 1 plus 3 into x by 2 whole square into, again derivative of 3 into x power 3 by 2, that is equal to 3 into x power 3 by 2 derivative, that is equal to 3 by 2 into x power 3 by 2 minus 1, that is equal to 1 by 2. That means x power n derivative n into x to the power of n minus 1. So therefore, any more cancellations here? Yes, you can cancel here. 2 you can cancel. So ultimately 3 3s are 9. So this is equal to root x into 9 by 1 plus 9x cube. Understand? So 9 by 1 plus 9x cube. He is given that the derivative is root x. This is a root x into g of x. Therefore, what is your g of x? 9 plus 9 by 1 plus 9x cube. So that is your answer. The only total problem lies in this is tan inverse of 2 tan a by 1 minus tan square. Writing this expression in this form and again simplifying this 2 tan inverse of x. So if you know that concept here, the problem will be very, very easy. Okay. So let us go for next problem. Welcome to third problem. The third problem is, let p of x be a polynomial of degree 4 having extremum at x is equal to 1, x is equal to 2, and limit extends to 1 plus p of x by x square is equal to 2, then the value of p of 2 is. So he is saying one word here, it has extremum at x is equal to 1, x is equal to 2. So here you have one concept here. What is meant by here extremum means? So here 1 and again 2, maybe extremum means maybe maximum value or maybe minimum value. Okay. So at x is equal to 1 and at x is equal to 2, it has a extremum, maybe maximum or maybe minimum. At extremum points, we have, so if you draw the tangent here, the tangent will be parallel to x-axis. Okay, now that means whatever may be the function, p dash of 1 is equal to 0. If it is a function is f of x, so therefore f dash of 1 is equal to 0, f dash of 2 is equal to 0. Understand? So if you find out the slope of the tangent at x is equal to 1, that will become 0. Why? Because these two tangents are parallel to x-axis. So if you know that, the problem will be almost over. So first one he is saying that p of x be a polynomial of degree 4. So we have to consider a polynomial. So what is that polynomial? P of x is equal to degree 4. Degree 4 means ax to the power of 4 plus bx cube plus cx square plus dx. A, B, C, D. 4, 3, 2, 1 plus e. Ax cube plus bx square plus cx square plus dx plus c. So let it be the polynomial of 4th degree. First we have that it has an extremum at 1 and 2. That means p dash of 1 is equal to 0 and p dash of 2 is equal to 0. That means at 1 and 2 it has extremum, maybe maximum or minimum. Okay, now, so if you draw the tangent at those points, those tangents will be parallel to x-axis. That's why p dash of 1 is equal to 0 and p dash of 2 is equal to 0. Now, what is a p dash of x? First of all, so this is equal to 4a x cube, 3b x square, 2cx plus d. Okay, now p dash of 1 means, p dash of 1 means 4a plus 3b plus 2c plus d is equal to 0. Call it as equation number 1. What is p dash of 2 means? Wherever x is there, substitute 2. 2 cube 8. 8 4s are 32. 32a. 2 square 4. 4 3s are 12. 12b. Here 2. 2 2s are 4. 4c. Plus d is equal to 0. Call it as second equation. So in A, B, C, D, we got two equations. Let us call it as 1 and 2. Now coming to this concept. Limit extends to 1 plus px by x square is equal to 2. So let us take that one. Limit extends to 1, that is equal to 1 plus p of x means what? Your polynomial. What is that polynomial? Ax to the power of 4 plus bx cube plus cx square plus dx plus e whole divided by x square is equal to 2. The limit value is given 2. Limit value is given 2. Now, if you simplify this, here x square will come. Here also cx square is there. Okay, now cx square there. So you can take x square common and we can simplify this. Okay. Right, welcome back. So here limit x tends to 1. So here what is the numerator function? Here ax to the power of 4 will come, ax to the power of 4, and bx cube will come plus bx cube, plus here one x square will come, no, here cx square, that is 1 plus cx square plus dx plus e whole divided by x square is equal to 2, right. See here, the limit of this function value is 2. The limit of that function value is 2. Observe the numerator and denominator. Here x to the power of 4, it x cube is there. Here a fourth degree is there. This is a second degree is there. That means if you divide each and everything here, that means x square will come here. Sorry, here x square will come, here x will come. This should be vanished. Why? Because there we are getting a finite value 2. That should be vanished. Okay, now that means here x square will get cancelled. Here 1 plus c value should be 2, d value should be 0, and e also should be 0. Then only you will get the limit value 2. Okay, here whatever may be that a and b values, whatever may be the a will afterwards. So if you get 1 plus c value is 2. And d value 0 and e value 0, then x square will get cancelled, you will get a 2. Understand this, that is the first thing you have to get. So from this c is equal to 1, c is equal to 1, d is equal to 0, e is equal to 0. Now substitute those values in the first and second equations. So if you substitute in the first equation, here c value is 1, so this is equal to 4a plus 3b plus 2 is equal to 0, equation number 3, d value 0. And substitute in 2. So this is equal to 32a plus 12b plus 4, d value is 0. So you can divide with 4. So this is equal to 8a plus 3b plus 1 is equal to 0, called as fourth equation. If you solve these two equations, that means if you subtract here minus, so you will get a value is 1 by 4, a value 1 by 4, and b value is minus 1. A value 1 by 4, b value is minus 1 you will get. Okay, now, right. Very easy. So 8a minus 4a, that is a 4a, these two will get cancelled, 1 minus 2 minus 1. 4a minus 1 is equal to 0, therefore a is equal to 1 by 4. So if you substitute a is equal to 1 by 4 here, 4 will get cancelled, 1. 1 plus 2, 3. 3b plus 3 is equal to 0, therefore b is equal to minus 1. So you got all values. You got a value, b value, c value, d value, e value. So therefore, what is your polynomial function? Let us see that. So let us see the polynomial function. So that is equal to, what is your polynomial function? P of x is equal to a value 1 by 4. That is 1 by 4 x to the power of 4. B value minus 1 minus x cube. C value 1 plus x square. So d value, e value both are 0. So this is your polynomial function. So he is asking p of 2. So therefore p of 2 is equal to 1 by 4 into 2 to the power of 4, that is equal to 16 minus 8 plus 4. So 4 4s are cancelled, 4 plus 4 0. 4 plus 4 8, 8 minus 8 0. So very easy problem. The only thing lies is the first concept that we have to remember is, when the function has extreme, means there the tangent drawn will be parallel to x-axis. Therefore, their first derivative at that point is equal to 0. Okay, now. And the second one is when such type of situation is given. So forget about these higher degrees, that is x power 4, x cube. So it has a finite value 2. It has a finite value. Limit has a finite value 2. That's why here 1 plus c value should be equal to 2, and there should not be d and there should not be e. Then only you will get a finite value 2. Okay, na? So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to this problem. The problem is the normal to the curve x square plus 2xy minus 3y square is equal to 0 at 1 comma 1. So there is a curve here at 1 comma 1 does not meet the curve again meet the curve again in second quadrant, meet the curve again in Q3, meet the curve again in Q4. See here, tangent means it will touches the curve at only one point. The normal means it may intersects. For example, if you see here, it is a curve, it is a tangent, it is a tangent. Okay, now it is tangent. Normal means again it will intersect the curve at a point of contact, again it may intersect at anywhere. Okay, now, right. So if you observe here, there is a curve here like this. Here we have drawn one tangent. We have drawn one tangent. The normal at this point of contact may intersect at any number of points. Try to understand here. The tangent touches the curve at only one point, but the normal intersects the curve at any number of points. That is the first point. So that is same he is saying. The normal which is drawn at 1, 1 meets the curve again at in which quadrant it is meeting. But if you go in general procedure for this problem, it takes a long time. Okay, now. So if you observe, this is a equation of pair of straight lines passing through origin. Why? Because here ax square plus 2hxy plus by square is equal to 0 type is there. Of course, that pair of straight lines passing through origin. So those conditions are also satisfying. Okay. Then first to try to factorize those, try to separate those two equations. Try to separate those equations. What is that pair of straight lines? X square plus 2xy minus 3y square is equal to 0. At 1 into minus 3, 3 into minus 1, you can write down. So that is x square minus xy plus 3xy minus 3y square is equal to 0. Factors, that is equal to, here you can take x common, x minus y. Here you can take 3y common, x minus y is equal to 0. Therefore, x minus y into x plus 3y is equal to 0. Therefore, x minus y is equal to 0 or x plus 3y is equal to 0. So, these are the two straight lines we got. X is equal to y, if you say that x is equal to y, and we can say that x is equal to x plus 3y is equal to 0. Okay, now, right. Now, let us try to, I am doing this problem without using any differentiation concept. Without using any differentiation concept, I am trying to solve this problem. So, first try to draw these two curves in the two-dimensional coordinate system. Okay, welcome back. So, if you see here, x is equal to y. So, this is a x-axis and a y-axis. Okay, now x is equal to y is a straight line passing through origin and lies entirely in passing through origin in first quadrant and second quadrant. This is y is equal to x line. Okay, now. So, here if you observe here, 3y is equal to minus x. So, this is the line passing through origin and lies in a second and fourth quadrant. So, this is a 3y or 3y plus x plus 3y is equal to 0 curve. So, that is x is equal to y curve, that is x plus 3y is equal to 0. A normal at 1, 1. If you observe, 1, 1 is a point on this line. So, here it will be 1, 1, 1, 1. Okay, now. If you draw a normal to this curve, total curve at 1, 1, that means normal means perpendicular. I have drawn this perpendicular. This is a perpendicular. Okay, I have drawn the perpendicular at 1, 1. 1, 1 lies at y is equal to x line. Then again, this normal intersects the curve at in which quadrant? Fourth quadrant. That's all over. So, your I think option D, option 4 is the right answer. So, the normal at 1, 1 again intersects the curve. Curve means straight lines also, pair of straight lines are also, we call them as a curve. Okay, right. Again, this normal again intersects the curve, in definitely it will intersect in the Q4 only. Why? Because it cannot intersect. So if you observe here, it cannot, it will go this side, and if it will go this side, it never intersect. Definitely it will intersect the curve at in Q4 only. By sheer observation, we can say that it cannot intersect in second quadrant, it cannot intersect in third quadrant, and it cannot intersect in first quadrant. Why? Because this line x plus 3y is equal to 0 line does not passes through the first quadrant. Cool. So there is a chance of this line to be intersected in the either second quadrant or fourth quadrant. Therefore, fourth quadrant only it will intersect. Just by observation, we can say directly. Okay, now, right? I hope that you understand this solution. So let us go for next problem. Dear students, welcome to this problem. He is asking one of the question. Discuss the differentiability of f of x is equal to step of x plus modulus of 1 minus x. Okay, now where x belongs to minus 1 comma 3. So here it is a function, it is a sum of two different functions. So one is step function, another is modulus function. So we have to be very careful about all the properties of this greatest integer function and this modulus function. But here he has asked to take the x value between minus 1 and 3 only. That means x value between, so this is minus 0, 1, 2, 3. So you should not take except minus 1 and 3. We have to observe the differentiability of this function between the intervals in the interval minus 1 and 3. It's very, very clear. This step function is not continuous at x is equal to 0, 1, 2. Let's wait on that. X is equal to 0, it is not continuous. 0, 1, 2. At 1 and 2. At 0, at 1 and 2, it has a breakage. Hence when there is a breakage, there won't be any question of differentiability. Hence, not differentiable at x is equal to 0, 1, comma 2. So the function is not continuous at 0, 1. That I am discussing about this step function. It is not continuous at x is equal to 0, 1, 2. Hence, we can declare that there is no question of differentiability. That means you cannot draw any tangent at a function where it discontinuous, right? Coming to this modulus of x. This function, that is 1 minus x, is modulus of 1 minus x is continuous at x is equal to 1, but not differentiable at x is equal to 1. It is continuous at x is equal to 1, but not differentiable at x. Why? Because at x is equal to 1, it will get a sharp edge. You will get a sharp edge, you will get. Okay, now that's why. From this, now the coming to this combination. If you observe the combination, both the combination, it is not differentiable at x is equal to 0, 1, 2 and not differentiable at x is equal to 1. So if you combine both the things, the function f of x is not differentiable at x is equal to 0, 1, 2. The given function is not differentiable at x is equal to 0, 1, 2. Understand this? The first thing is, the first function is not differentiable at 0, 1, 2 and the second function is not differentiable at x is equal to 1. Why? Because at x is equal to 1, you will have a sharp edge. If you combine these two together, definitely the function is not differentiable at 0, 1, 2. Understand? And also they are discontinuous also. May be continuous, may be not discontinuous, that is a different matter. But f of x is surely not differentiable at x is equal to 1, 0, 1, 2. Okay, na? So I hope that you understand these solutions. So dear students, these are all problems I have chosen from various previous year question papers. At the tomorrow's class, I will explain problems from the Senge's textbooks. Okay, na? So until then, all the best.